Before we leave our discussion of substitution reactions, we want to talk a little bit about intramolecular versus intermolecular reactions. So these are reactions that would be competing with each other whenever we have a molecule such as this that has both a nucleophile and an electrophile in the same molecule. So if the conditions are right, the nucleophile can attack the carbon that is electrophilic and eliminate the leaving group attached to it. And that will lead to a ring being formed. It is also possible that a molecule that has both a nucleophile and an electrophile, instead of reacting with itself, would react with another molecule of the same kind. So for example, the nucleophile of one molecule would react with the electrophilic site of another molecule. That will lead to an extension of the carbon chain rather than forming a ring. So this is an example of an intermolecular reaction where the reaction occurs between two molecules as opposed to an intramolecular reaction where the reaction occurs within the same molecule. Now, intramolecular reactions are highly favored whenever we can form a really stable ring. So that happens with 5 and 6 member rings. So if you can form a 5 or a 6 member ring, very likely that you will have an intramolecular reaction rather than intermolecular reaction. Whenever we have the possibility of forming a 3 or 4 member ring, which have high angle and high torsional energy, it is less likely for an intramolecular reaction to occur. Larger rings are also unlikely to form due to the fact that the nucleophile and electrophile are very far apart. So in those cases, whenever you're likely to form a 7-member ring or larger, it is also unlikely that an intramolecular reaction will occur. You can still get those reactions, whether it's forming a small ring or a larger ring, you can still make that happen if you use a very low concentration of the reactant. So in other words, if you take your reactant, whatever has both the nucleophile and electrophile in the same molecule, and you put it in a sea of solvent, it is very unlikely that a molecule of the reactant would find another molecule in that solvent. And so it is, even though it is less likely to form a 3, 4 member ring or very large ring, because of the concentration, very dilute concentration, you can still get an intramolecular reaction. However, if you move to a higher concentration, you can shift to getting an intermolecular reaction where one molecule of the reactant would react with a different one. Here's an actual example of an intramolecular reaction. Here we have an alcohol and a chloride, which is attached to a carbon. And if we add base, so sodium hydride is an example of a base. The hydride has a negative charge. That hydrogen can remove this hydrogen on the alcohol, which is the most acidic hydrogen in this molecule. That would put a negative charge on the oxygen as shown here. So hydrogen removes that hydrogen, puts a negative charge on the oxygen. That makes the oxygen a better nucleophile than we see here because of the negative charge. That oxygen can now attack this carbon, the electrophilic carbon, and eliminate the leaving group, leading to a 6-member ether. So oxygen is one atom, and then there are 5 carbons in between this electrophilic site and this oxygen. So in total, we get a 6-member ring at the end of this reaction. So this is an example of an intramolecular reaction. This is one that we'll discuss in more detail later this semester.